All right, we are week 11, day one, continuing on with our Django module. Last week we looked into Django, what Django is, and models, and then we looked a little bit on Saturday on those relationships between models, which you will get a chance to practice tonight, since we didn't have much time on Saturday for that. Today we are extending on Django even more. Because so far we've been working with our models in the shell in our terminal, which is great for like messing around with it. But our goal is to have a database that holds data that we receive from a web application and in turn returns that data up on our web application UI for everybody to see. So there's got to be a way for this data to move back and forth between our database and our what we've created in Django and then what will be our React front end. So we are now going to start diving into the Django REST framework. And we have worked with third-party APIs in the past, right? When we started looking at a little bit at front-end development with HTML, CSS, and JavaScript. We also looked at fetch and working with the await, async await, fetch functions and grabbing that data from those third-party APIs in JSON format. So we are going to start doing the same thing with our data from our database using Django's built-in REST framework. So all the third-party APIs we looked at when we were messing with them and getting back JSON data were RESTful APIs. So they return JSON for us, and that is what we are using in our Django REST framework. So we are going to continue on with our Pokemon example to kind of look at how we can start exposing this data through an API. First note, I updated this. It used to not say this, but I updated this because if you are using the application as of the end of day 4 branch, remember when I told you that if you make them into two separate apps, you might have some issues with the foreign key relationship between them? So if you start with the application as it is at the end of that day, which I have here, and you try to migrate all together, make migrations and migrate all together, you're going to have a ton of errors thrown at you with foreign key constraints and all the like in the terminal here. Because they have a move app here with the move model individual, and then the Pokemon app here with the Pokemon model, still inheriting from move or grabbing, it's not inheriting, still related to move with those with the many-to-many relationship. But they're two different apps. So when we go make migrations, it's going to run both make migrations at the same time and add a little file here, which this one already has an initial migration ready to go to the database. Pokemon does not. So that's good, and that's what you want. If you make migrations and migrate, then it's going to have both initial migrations and then try to push them into the database. And this one's going to yell, I can't do that because there's no such thing as a move from move app right now. So in the README, it says if you're starting from this one where we have a separate move app from the Pokemon app, then go ahead and you'll make migrations for just move app first. And it should tell you nothing's changed because it has an initial migration ready to go. But make sure you're in your virtual environment, as always, when you're working in here. Otherwise, you'll see a Django error. But you would just do the same thing that you would do to make migrations regularly. But instead, you would just target the move app. So by saying make migrations move app, I am specifically telling Django to just go ahead and look at this one and migrate everything with that app first. Connection refused. Is the server running? Uh-oh. Did I wait too long and need to restart this? We will see. But it says no changes. Oh, because we're not, sorry, I haven't got my Docker. That's right, my Docker image running. But it says no changes detected in Move app because we have an initial migration ready to go into the database. Let's go ahead and get that up and running. Docker compose up -d. What are we saying here? Oh, Docker Composer up. Oh my gosh, I swear if I'm actually coming down with the flu and we're gonna have a night like this. Okay, so now my database is up and running. Um, I should not have data in there. It took from a cached version, obviously, because it didn't do a lot of craziness. So we will see how this works. I might need to trash this and start again. But let's go ahead now and make our migrate these changes that are here from the Move app. Migrate this into the database first. So it's going to create the Move model in our database first. So now we can see when we migrate, it did just the Move app and all the rest of the built-in stuff that Django has. Now we need to migrate our Pokemon app, which has the Pokemon model that has a many-to-many relationship with the moves. So now we can just make migrations and migrate as usual, because at this point, the only thing left to make migrations and migrate will be what's in this model here, if that makes sense. So this is only, and we can see it's set up now, the Pokemon model. We can see in our migrations folder, now there's an initial one for the Pokemon model, and we're going to push that into the database. Okay, good. So this is only what you have to do, extra steps, if you choose to pick up where where I was supposed to leave off from Saturday on this end of day 4 branch with 2 separate apps in here instead of all in one. So on Saturday, I had move within this file, all underneath Pokemon app. So you don't have to do this step-by-step migration if you have everything underneath one model and one app. Okay.
Hey, Tiffany, I guess I'm a little confused. So if you specify the Move app, you get the Move app. But if you don't specify anything, does it automatically go for like all apps or?
Yep,
Okay.
exactly. It will look at all changes that would need to happen for models in all applications. So, yeah, that's a good question. And I wanted to show that you can target one individually with that by calling out the specific app. That helps when you're dealing with these relationship issues if you decide to use separate apps. And remember, when you have an app created, you may need to make sure it goes into this installed apps in your settings file. Okay, so that's something that is in the README. If you follow along with the README on day 3 of this example series, it will have you adding that Move app as well. We did not do this when I showed you because we did everything all in one Pokemon app.
So I just want to make sure I'm following as well. I'm pretty sure Scott just asked the exact same thing, but so what what you're showing us right now is originally what we were gonna do on Saturday, but we did everything under the Pokemon app.
Mhm.
And the Move app, what was the Move app trying to? Was it trying to add something to, or just add something to the Pokemon app, or was it trying to change something in the Pokemon app?
So the Move app is just storing everything that we had put all underneath one app on Saturday. So in the Move
Okay,
app,
gotcha, gotcha.
we have the Move model, and then we also have the Move tests, and then the Move validators. So all those we put underneath one app in all of these files, but you can break it out and have it be its own app where it has its own model and its own tests and validators. And then we just
Got it.
when we're doing the relationship, we import from move app models,
Oh,
import that
okay.
move.
Got it.
So this is like the separation of concerns type thing. You know, you tried the OOP principle where you're trying to keep everything as separate as possible. So if something's messing up, it's easier to target and dig into the right component versus having one huge app with a whole bunch of models that might not be related. So this is technically the um, correct way to do this, but it's not very beginner friendly because of the migrations, having to make sure you migrate in the order you need those tables to exist in the database. So think of that SQL file, and you know how we move the model up on top of the Pokemon model because we want to make sure that the model is created before anything else tries referencing it.
We still have to do that Python manage startup, right? On the Move app, like to create that Move app.
Yes, that's correct. Yep, that's how
Okay.
that is created, is that Python manage.py start app. Um, let's see, let me get the curriculum back up. So if you go back on day 4 of week 12, it actually runs through all of those steps to get the creation of the separate app and tells you to put this in, you know, the models file under that one. So this README will walk you through how to create that separate app. I wanted y'all to really focus on the associations part of it and how they're related versus creating a new app. So that's why I just threw them all in one file. But today we are going to pick up where it left off on day 4 and just run with the 2 separate models because it won't really matter for today's lesson. So if you are following along, picking up from where we left off on Saturday, that's fine. You're not going to have to do anything extra until it comes to the creating an endpoint for our moves. So when I say endpoint, what am I referring to?
The API endpoint, like the Python function that's going to return something.
Yes, exactly. Yep. When I say endpoint or when anybody else says endpoint, they're typically referring to an API and then the URL that you're going to hit for the data that's returned from that. So yes, exactly. Just want to make sure we're all following along because I'm going to throw that around a lot when we're talking about what we're setting up today. So we've got now, I've got everything migrated. So now we need a way to be able to, well, let's add our Pokemon in there too to make sure that that exists before I start doing anything with getting the data back. So let's go into our shell. We're still doing it in the shell because even though we can do this in the admin page, I want y'all to get used to the Python I guess syntax for grabbing Pokemon objects and move objects and stuff like that because we're about to do something similar in a different file here in a second. So let's go Python manage.py shell. Now we're in the shell and we're gonna do our creation of our Pokemon, which I'm just gonna throw this up here. This is in the README for today, but it's further down. I want the data in here first before we start thinking about grabbing the data. So it's just another from that models, let's import the move model, and from this model, let's import Pokemon. We're going to say that Psychic is a move, give it that name, save it, and we're going to create the Pokemon Charizard and save that. Now I'm going to take and add that move to Charizard. And this, okay. So we should be good now. let's see, triggers are moves.all, because .all shows us everything in a many-to-many relationship or in the one-to-many as long as it's on the many side. Okay, so we can see our move psychic got added correctly. So now we can get out of here. We've set up our data in the database, it exists there. Now I want to make a way for people to hit a URL endpoint and get this data back of this Pokemon with all the moves associated with it. And of course, all of our endpoints should be spitting out JSON because that is what everybody expects from a RESTful API. And our README has an example of kind of what we expect it to look like when they make a request to get data from us. So our goal is to create something that looks like this. So we are going to use Django REST framework to do this, and it involves actually installing it. It is not part of just the Django package that you've installed. We now need to pip install Django REST framework, and then we're going to add that to our requirements file. So everybody else coming in afterwards knows that they need to install that as well. So make sure you're in your virtual environment, and let's pip install. It's all one word, Django REST framework. I've already installed this in here while practicing the lecture and making sure it all works smoothly. So y'all may or may not have it already installed as well. Let's pip freeze into requirements.txt. Okay, so then it should update with now adding Django REST framework as a dependency in our requirements text file. All right, so everybody keeping up so far. We're going to use Django REST framework. We need to install it. Now, I've installed Django REST framework. It's an additional thing I'm going to be using in here in this project. So we need to go into our settings and add it into one of our installed apps because it's something that's not a part of Django at base here. It's another dependency we've installed that we need to go ahead and have access to. So you're going to add in here REST framework. Okay, and I would always just trail a comma just in case. It doesn't hurt, and then that way you will never forget a comma when entering down to the next line. So I've added REST framework to our installed apps. Now we're going to actually start setting up what's called a view. So the other day when I said you don't really get to learn about model view controller setup here in this course, well, I'm still going to tell you a little bit about it. In Django, a view, or in DRF, a view is actually a controller. So if you hear people talking about MVC and they're talking about controllers, that is the portion of your application that has the logic to decide what data to return in the request. So the controller / in Django, it is called a view, not confusing at all because you'll get out in the real world. View does not equal view in the typical sense. But Django's view is a controller. The view is where we are going to put down logic to determine what data is going to be presented in our endpoint. So views go in our apps. Pretty much everything we create is going to go in our apps. Nothing goes in this project except for we change settings, and we're going to change URLs too in a little bit. But we're going to create a new file in our app called views.py. Oh, no, we're not going to create it. It already exists. My bad. It's already here. It should be here in both. We're going to create another file in a second. But on this page, we're going to create a view. Gives you a little introduction in the top of the README that says, what are views? And this is, the view is basically one big function, and it's going to take in an HTTP request and then return an HTTP response. and it could be JSON, which is what we're going to do in our Django REST framework. But there are options to create like an HTML template to return in the response as well. So you can actually return a full web page in our response in our view. But yes, this is where we're going to take in requests from our web app and then return a response in return. We lean heavily into OOP design with this. We don't really class-based views. I guess it's just the fact that we make like our models are classes, so we're going to have class here as well. Okay, so let's grab this code snippet from the README and walk through what each of these things means for our view. Is anybody like super confused right now what a view is for our Django REST framework? I think when we start looking at it, it might make a little more sense. Okay, lots of comments on this. And I did not pause long enough to see if anybody had any questions right off the bat here before I start explaining more. Are we following along what a view is roughly? It's where our logic is going to grab the data from our database. Okay, so in here we have a ton of comments, so you can follow along with the README and really read through and understand what each of these things are. Obviously, this top part is all of the dependencies that we will be, or the libraries that we will be importing and using different methods and models from. From REST framework views, we're going to import something called API view. This is a class that we will inherit from in order to get access to all the special behind the scenes things that DRF does for us. This is probably one of the most used views that you will select in this course, but there are other views you can pick as well. We don't dive too much into those. I can look in the documentation and get you a link if you want to explore other views, but API view is what we use. It's kind of a nice standard, like we're gonna deliver some JSON type view. And then we're also importing response. That allows us to, as it says, get our data into a response that is appropriate for HTTP transmission. Of course, we got to bring in our model from Pokemon because we are going to be talking to the database that Pokemon, like we're going to be talking to this table in the database, right? We want to pull out Pokemon data from this table. So we need to bring that model in here so we can interact with that in our database. Same with the move one. We need to interact with that as well because we want to grab moves from there. Serializers. So we already know that Django gives us objects, right? We know it doesn't talk in SQL and do SQL commands, so we have to it does some things behind the scenes to translate what we're doing in Python with our objects and how it translates it and puts it into SQL into the database. So the same kind of thing is true here, where we're not going to have JSON with what we pull out of the database. So we need to use serializers to help manipulate our Python objects into JSON data. And the Django core serializer actually, as you see down here, it turns it into a binary string. So after this lecture, I will do an optional one to show y'all using the DRF serializer, which is the Django REST framework serializer. That actually returns JSON. So you don't have to do this two-step thing here of serialize and then JSON loads. We'll go into that in a second, but I will show that as an optional thing after this lecture. We will go into the DRF serializer when we learn about nested data within our models. So you don't have to attend to learn about DRF serializers, we'll get there. But I just thought it was weird that we're using Django serializers. We should be using Django REST framework. Kind of a little rant on my side. Anyways, but we need to use a serializer because, as I said, our Django works in Python, which has objects, not JSON data. So we need to manipulate it in order to present it as JSON. And we're going to import JSON because we have to turn this binary string that this serializer manipulates into JSON for our response. Okay, any questions on this top part here that I kind of blew through? Okay, we will keep going then. It will pretty much, all of your views will pretty much mirror this. Most of the time, you're always going to import these, and you're always going to import your models, and then you're always going to import a serializer as well in JSON if you're using the Django serializer. Okay, so now here is where we create our view, which is a controller that tells the backend here what data we are selecting to provide in a response. So it's a class, just like everything else, right? Our model was a class, and we inherited from models.model. Our view is also a class that we are inheriting from the Django REST framework's built-in API view. So we are inheriting from that view. And then we define a method underneath that view. This is a GET request. We will learn more about the different types of requests through APIs when we learn about CRUD. I think that's in the next few days, actually. And I look forward. But for now, a GET request is just getting data from the database. It's basically all we've been doing up until this point in class is just grabbing data from a third-party API and viewing it on our screen. That's a GET request. You're just saying, hey, give me that data that exists in your database. So here we are making a method that is going to define actions for a GET request. And it will also, just like OOP we're used to, always have self as the first parameter, but then the next parameter is a request. This is what I was talking about earlier, where these are all functions within this view, but instead of taking in regular parameters, they're taking in the request, an HTTP request from our front end. So it will take in a request. Doesn't matter what's in there at this point because we are just simply, they're just going to say, hey, can we have some data? And we give it back to them. So we just say any single request HTTP hit to our endpoint, let's go ahead and just provide up some data. So here is where all those queries that we were doing in our shell is going to come into play. The important part of every view that you create, you will have to have a query for data first, then you will have to serialize the data, and then you return it in response. Okay, so if we want to get all Pokemon from our database, you need to first query using Django's query language. Okay, so when we were learning like Pokemon.objects.all, that was a query to get all Pokemon, right? So we could use that here. They didn't use that here. Instead, they're getting a little bit fancy. They're using something saying order by. So this is saying get all Pokemon from the Pokemon table and then doing an order by name is the equivalent SQL. So in order to help you with these, this query portion of each view, each request, or for your GET requests and your posts and puts and all the stuff you'll be learning eventually, in order to help with this query portion, I've got some resources that I will link in the chat in Slack after we go through our lecture. In Django documentation, there's this whole thing that I think is better. There's a couple of different sections. There's one that actually has like just the types of queries, but then this one says making queries. and it's a little more descriptive on how you can grab information from, let's see. So here we have retrieving all objects. So that's what we're used to. But then you can use a filter, and it tells you how to use filter. So this one looks like on that field, as long as that year is equal to 2006. Chaining filters. We can do getting a single object with get. We can, let's see, limit by slicing. Field lookups. We can say filter by a specific field. So this would be a get all entry objects where pub date is less than or equal to this date. So this is a good document to help you see, and it even has the SQL. See, look, it has the SQL underneath, what equals the Django specific syntax for your queries. So the first step of every view is deciding what type of data you want to get out of your database. And then after that, you can go ahead and break it down in a way that can be serialized and presented through the response. So this will help you figure out how to get that data, because you don't always have to do a select all objects and then handle it programmatically after that in Python. You can select specific objects using Django's query. So think about that when you're designing. That's one thing. Something that might be a little easier for y'all to see. I know it's super bright. W3 Schools has field lookup references. So these are all the things you can add to your like Pokemon.objects dot, and then you can say it's a filter. Oh, these are all probably filters then. Let's see, ends with, yeah. So these are all filter items that you can add. Now, if you see, it's the field name here, and then they always do 2 underscores between like the field and then the type of filter you're doing on that field. So just be careful with the syntax there, but this is another good one. I will link y'all to help you with queries against your database to grab the data you want for your view. Any questions on those queries? For now, we're sticking with easy ones, but oh, go ahead.
So it looks like everything is dot objects.
Mm-hmm.
How, like on the other page, the first one in the Django documentation, there was like the SQL translation under it where it specified a table, but that table name's not actually in the Django query.
Let me see which one that is. So further up here, maybe.
Yeah, it was up near the top where all the easy stuff is. It was above that one, right
It
there.
looks okay.
So entry.objects.filter and the equivalent in SQL is select all from blog entry, but where is blog entry
yeah,
specified?
that's, I mean, it is supposed to be like this. So I guess in SQL, the table name would probably be like blog entry. But our model name is probably entry, is what I'm guessing.
Okay, so it goes off the model name.
Yes, yes. So like Pokemon's our model name. So that's why we're doing Pokemon.objects.all. And then moves, like we did move.objects.all. I'm trying to see if we have, okay, yeah. So at the top here, it does show the models that all these queries are based on in the documentation. So you can see blog, but entry. Entry is another model here. So yeah, that is kind of weird that they have the SQL table, I guess, a different name than what this is, but
No, it makes sense now that I know the model is the first thing in that query.
yep, 100%. I definitely think we should do more time in queries. That's why I took the time to find this documentation, but we don't have a lesson for queries. So if you all want help, I do like doing Django queries because I like doing SQL queries, and it's kind of fun chaining together all of the where stuff that you can do with the filters and whatnot. Those are good questions. And again, it's helpful because you don't, it takes a long time if you're selecting all from a database that has hundreds of thousands to millions of entries in it. So you want to do a query that is very specific to what you want to return. For our purposes, though, we're able to do this. We know there's only one Pokemon in this database, so we are able to go ahead and just grab all these Pokemon objects and order by the name. So this one, it didn't have to put all afterwards. It just said Pokemon objects to order by. But you could also do, oh, oops. They just won't be in order then. But it's the same thing. We're gonna keep it in order. Okay, so first step in our GET request is always make the query to the database using our Django syntax. Okay, after that, we can see, oh, we can't send the query back as a JSON response because it's a query set, right? When we could see that here. When I looked at the Pokemon moves, it gave me a query set. That's what Django gives us, is a query set. It doesn't give us JSON. It's not friendly to be able to send in our response. So we have to take that query set and turn it into a binary string here. Again, I will show you a different way that just goes ahead and turns it into JSON. But for this class, we're going to learn how to put it into a binary string first. Just use this syntax always. You're going to say some variable name that you're storing it in equals serialize, and you want to turn it into JSON. Pokemon, I guess, is the name of the object. Or the query set, sorry. Pokemon's the name of the query set. So you just follow this syntax, changing out, the variable name and the name of the query set that you are trying to serialize. After you serialize it into a binary string, then now you need to change it into JSON format. So here is where we change it using JSON loads. So we take that serialized binary data and change it into JSON by feeding it into this JSON loads method. Okay, so doesn't matter if you don't follow along with these two lines directly, just take a note of this syntax and realize where the variable names are being drawn from and used again, and just follow suit. You will have success. So we query, we serialize the information, we turn it into JSON. Now, if we just stopped there, we think about, we get back our query set, our Pokemon moves. How does that look in our database? And you can see it here. Our moves are foreign keys, right? They're going to be saved in the Pokemon model as numbers, foreign keys, integers. So moves is a list of integers, but we don't want to throw back at whoever's querying this endpoint. We don't want to give them just a list of numbers. We want to give them the move that's associated with that ID in that list of Pokemon moves. So in order to get now the move data, instead of just that foreign key, we have to loop through all those Pokemon, the JSON Pokemon, and query the database to grab the move objects now. So this is doing the same thing that we did up here, but now it's a little sub-query because we need to get the moves just like we got the Pokemon. So this one's saying, oh, go ahead.
Is that for loop using Django REST framework?
This is just regular Python.
Okay. Because I was doing some research, like I read this before, like instead of procrastinating this for today. So I think you don't have to do it a for loop, but I think it's more efficient to use Java runtime or Java REST framework. But I was just curious because
Yeah, so
Um,
there's actually, when we use Django REST framework serializers, which returns JSON,
mhm.
there's also a built-in method with the Django REST framework that's called, I wrote it down because I found something easier too when I was researching. I think it's preload. Um, Prefetch. So you can use a
Yeah,
method called prefetch related, and it
yeah,
will grab all this like move object data without having to do a separate query. Because this is
yeah,
super inefficient, right?
yeah, yeah.
We're
It loops
querying
through
for
all the
Pokemon, and then we're querying within the Pokemon again. It's yeah.
yeah. So like if you have 2,000 Pokemon, it'll like
Oh gosh.
it'll be looping through every single one. And so
And
it'll
then
be
looping
insanely
through all
slow.
the grabbing all those moves. Yeah, yeah. It's this is inefficient, but this is fine for learning how we're grabbing data and presenting it. There's a better way to do this though, a more efficient way. But essentially this is doing a subquery within, after we've grabbed our Pokemon data, it's doing the same thing again where it's querying. It's getting all the moves associated with that Pokemon. And then it is taking that, and they just made this a one-liner now. Instead of having two lines for serialize and JSON loads, they're serializing here and then they're JSON loading on the outside. So same exact process, query, serialize, make sure it's JSON, and then finally we return a response of that JSON value. So this is what all your views are going to look like for these GET requests. It will get a little more fancy when we do other types of requests, but right now we're just focusing on GET and a general structure for that. Okay, any questions with the GET requests there, the view? Okay, so now we have a view that is getting the data we want and putting it in JSON and presenting it forward as a response. But how are people going to get this? We don't have an endpoint just yet, but we can make an endpoint using a URLs file. So we're going to have two URLs file. There's a URLs file that is built in at your project level. And this one is going to hold all URLs for your entire project. So you can put URLs in your Move app. You can also put some in the Pokemon app, and we will contain them all in here. This is going to be our root URL. So when we go to the admin panel, we usually do localhost 8000/admin. So this is going to be the root URL to access our API. So we're going to create now URL endpoints for people to go visit or fetch from and get that response back from our API. So first things first, we're going to make a base URL here at the root of our project. We're going to make a new path, and we're going to call this one typically for, let's see, it says RESTful API design dictates certain structure. You will see this in most all third-party APIs you go to. There will have API in there, and then there will be the version number of that API. So a lot of them you will see API/v1, and then you will have different other, I guess, other, what do I want to say? It looks like you follow it by a pluralized noun, but we'll be building on that anyways. It's just further more to the URL than just API and v1. So typically it's API version 1, and then I guess they said a plural version of the noun, so we'll follow that. That's fine. So everybody going to API v1 Pokemon, I want them to also use URLs that I'm going to throw in this Pokemon app. And we'll see in a second, this will be kind of, I can't fully explain this until we do both of these. Oh, not admin site. Shoot. I meant Pokemon app. We have to include, my bad. It's been a minute since I've seen it. We include Pokemon. And we can see includes complaining. We're gonna download that library in a second here. Or module, sorry. I think that's what we call it in Django and Python. URLs. Okay. So basically this is saying everybody going to this URL also include URLs that we're going to define underneath our Pokemon app. And we can see URL needs to be imported. That's actually from Django URLs or URLs. Include needs to be imported. So we just throw it up in this URLs import here. Okay, so now I've told it, everybody that goes there include Pokemon app URLs. So let's make a Pokemon app URLs.py file. And it's going to basically follow the same template, but we're going to have different paths, okay? So in here, I guess we don't need to include, because we're not going to include any. Here is where we're going to specify the actual full URL that people will have to visit to make or send a request to get data from our API. So typically you want people, when they visit just this Pokemon URL, to just get all Pokemon associated with this in our database. So in order to say just go to this URL and that's it with nothing else on it, we're going to create a path that is literally empty. So there's going to be no additional stuff on it afterwards. This right here is what's going to be tacked on the end of this URL. So if I had, let's say I wanted to direct them to a certain like Pokemon like Clefairy or whatever, then you can add that in here as additional onto the end of the URL. So then they'd have to go to API/v1/Pokemon/Clefairy to get everything back that I'm about to list here. Does that make sense? This whole two-part thing is just building, this is the root URL, and then every URL we define, this path we define within our app is going to be appended on to the end of this root URL. Does that make sense? Or do I need to try to explain it a different way or find a different visual? Okay, we will keep rolling with it then. So right now, since I haven't thrown anything else in here, this path is just going to be this URL, of course, on the end of our local host. So we've got a path defined. Now, when we define a path in our app, we need to also define what view is going to present the data for this endpoint. Okay, so we've made this all Pokemon get view. The view we pull from just the name of the class. You don't have to grab the functions, the methods that we define underneath the class. You just pull from the class that you created. And let's see here, we'll just roll with it. So we're gonna go from all Pokemon, which we haven't imported yet. And we're gonna say we're gonna treat it as a view. Okay, let's import it so it stops yelling at us from not models, views. Okay. So we're saying anybody that goes to this path for this endpoint, we're going to use that all Pokemon view as a view. And we give it a name. I don't know why. I forget why. I have to look up why we give it a name. I think it has to do when we get a little more involved in our views. I'll have to look it up. But it's just good practice to have a name. So this one, this view here is going to give us all Pokemon. So I assume we'll name future endpoints with like Pokemon by ID or, any other way we could select data. Okay, so now that we've got a URL path, anybody that comes to this URL, which is going to be our base URL, which is localhost 8000/API/v1/Pokemon /nothing, because we didn't put anything here. Everybody that visits there or makes a request through Postman or wherever, a fetch, they will have this view handle presenting the data, which is this view right here. Okay, so before people can get data from our API, we have to actually run our server, because right now it's all just sitting here. There's nothing listening for requests, HTTP requests. So we need to run our server so it's listening for HTTP requests. So we do Python manage.py run server. When we do that, we can see your application's running on port 8000. That is the default for our Django REST framework. Usually our backends here, listening on port 8000. We can see that starting development server at our local host 8000, and it's just sitting here listening. This is a good sign. This just means it's hanging out, it's ready for requests. So now we can use Postman. Oh, I already did one earlier. Let's clear this out. Clear response. Okay, so let's use Postman to test our endpoint that we made. So we said that it was going to be at our local host 8000 and then our base URL, which was that, which is API/v1/Pokemon. And then if I had other stuff in the other URLs file, I would tack that on here, but I don't. It's just empty. This should be our endpoint that we're going to make a request to, a GET request for that data. And we can see we got 200 okay, which is great. Look, on our server, it listened and it received a GET request. And then this is the response it's giving back after it got that request, but this is that server listening and returning a response successfully. And we can see it grabbed the data we wanted. It's got our Charizard fully laid out. It's got our moves fully laid out. This is interesting though, because the way that the serializer through Django works, it has on here these fields called these keys of model, PK, and fields. It's a lot of extra. So I can show you the DRF serializer, which literally will only return the Pokemon and its moves instead of all this extra metadata with it that we don't need. But because of the way we serialized using Django's core serializer, this is how that response is formatted. Any questions with how we did this view and this URL? Okay, I'm gonna fly through the moves so we have time to practice this. So moves, same thing. We're going to go under our views to make a view for data to be returned when somebody creates a request to our server for data through our API. So here we can see it imported all the same things. Imported the model, the serializers, JSON. This class we've called all moves for this API view. Kind of similar to how we created all Pokemon there. Oops. And it has a GET request underneath, which is the GET for data. Here we can see it's got everything all in one. So here's the query right here, where we're doing get us all the moved objects in order by name. Then we serialize it there. and then we JSON loads it here, and then we provide the response of it after it's been turned into JSON. So this is our moves view. Let's make a moves endpoint. The URL. So just like before, we're going to need to add another path to point to the move URLs. So let's add path. We're going to do API/v1/moves. This one will include, we're going to do move app. And we can see while I'm working, the server's changing down here. So if you do things that it doesn't like, it's going to error out. But if you do things it does like, it will eventually reset itself and look good again listening. So let's see, move app.urls. Okay, so let's create a move app URLs where we will put the remainder of the URL portion there. And we can see we're doing the same thing we're doing with Pokemon, where we're not going to add on anymore to append to the URL. We're going to just go ahead and make anybody that visits that moves is going to see all move. We're going to use our all moves view to grab the data and return in the response. I didn't have a comma. Okay, so now that I've fixed everything, my server's happy again. It's back to listening and not complaining about any errors down here, because now I have fully formatted URLs here and the views all defined. Let's go ahead and visit this API v1/moves, and we have nothing else on the end of that, and see if we can get all the moves in the database. And we do. Perfect, because we only have one move in there. All right, that was the lecture for today. Any questions?
Can you share with us information you have on the Move app? Since last time we did it differently, right? What do you have in models? Can I take a look at it real quick?
Yeah. So it's just the move model that we had thrown up above our Pokemon model in the same
Oh,
file.
okay. Okay. Got it. Thank you.
Yeah, everything's just separated. If you're still working in the same one, you would not need to do an additional URLs and views file. I would just simply put it all under one URL. And at that point, if it was all under Pokemon, I would probably do, where's my Pokemon URLs? I would probably do another path that's like, oops. And I want to say I throw a slash on in front just to be safe. Maybe not. And then I'd probably do like a all moves as view here. So I'd probably have a route under the Pokemon app that points to moves, and then under my views underneath all Pokemon, I'd probably make a class all moves. And this is only if I had everything in one file. If I had both models in one file in one app and I didn't have a separate app, I would just throw another view here called all moves, where I am querying for all moves, serializing that data. So then in our URLs, let's close all these extra ones. In our URLs, I would be able to point to that one, and it would grab that view to serve up the data, if that makes sense. The only reason I had two separate files for URLs and view, or doing these all in this two separate, is because we have two separate apps. If we had one app, I would just do everything under these two URLs and views. Any other questions before I stop recording? We go over our challenge for the day.
Is include a library or a built-in method, or what is include?
I think it's a library. Is that what we call it? Where I was under my main URLs. So it's a I guess it's a
Oh,
built method.
okay.
It's a method within the, where is that from? Django.urls module. Or function method, whatever. So this is the module and then, or slash library. I guess it's all part of Django. And then we got to pull in that method that we're calling for function. Oh, my server hates me because I did this. Now it doesn't. Good old OOP can put pass underneath our class and it's happy. All right, any other questions? These are good questions. It doesn't really matter the order you do this in because you have to have all three of these things set up before any of it works. So if you want to start with writing your URLs and then writing your view after that, you can, but it's easier. I don't know. I find it's easier to write the view first to figure out what data you're getting and then the name of it, because you're going to have to throw that in your URL to say that this endpoint is using this view. But you can go ahead and think ahead and say, I'm going to make one called All Pokemon eventually and do your URLs first, but it's up to you. Just got to make sure you do your view, your URL, and then add them to your main URLs as well. Okay, I will stop recording and we will go over our challenge for the day.